We are in the woods, as they say here in Finland, in Mukko, Lappeenranta, in the south of Finland, carrying out an in-situ remediation of chlorinated solvent-contaminated groundwater. This forms part of a government-driven project which consists of 4 different cases in Finland that are all contaminated by chlorinated solvents.
Nordic Envicon Finland is a main contractor here, and we use RGS technology and their design and chemicals, and RGS Nordic from Sweden is doing the injection work. So we are 3 companies doing the work together, and I am a project leader of the whole case. So actually we have 3 cases now in Finland going on.
The legacy contamination found at Mukko, Lappeenranta was caused by historic activities of a former metal processing facility in the 1990s, where occasional spills and leakages resulted in the contamination of the soil and groundwater with PCE of up to 1500 micrograms per litre.
How this was found, this contamination, was that we have this 1 kilometer from the source area up there is a groundwater abstraction well for the municipal water supply, and there was found some PCE.
After up to 5 micrograms per litre of PCE was detected in the abstraction well, site investigations were undertaken by environmental consultants Poiri and later Ramble. It was found that the local geology consists of a glacial formation with a series of valleys, which channels the groundwater flow, resulting in a flow rate of 2,000 metres per year.
This site is unusual in that we're dealing with a kilometre-long PCE plume that is only about 20 metres wide. Now that's unusual because you would normally expect to see some daughter products being produced as that PCE is broken down in the groundwater. But that's not happening here because we're dealing with an incredibly fast-flowing, highly aerobic aquifer that's preventing the degradation of PCE. So to overcome this, we decided to deploy an integrated remediation treatment strategy.
RGS Nordic and REGENESIS first worked together to develop the design. The result is a 2-pronged approach: enhanced reductive dechlorination in the source area to achieve a significant contaminant mass reduction, and in-situ sorption and enhanced biodegradation in the Plume area to protect the drinking water abstraction well. Source treatment was carried out in autumn. REGENESIS electron donor 3D microemulsion, 3DME, together with BDI Plus, our bioaugmentation technology, were injected to stimulate and enhance the reductive dechlorination process.
We started to inject between 7 and 13 meters below zero ground. It went very well. We injected approximately 8,000 liters per point.
Now it is spring and the second phase of the works are being carried out. The injection of Plume stop colloidal activated carbon in a barrier formation, together with HRC, a high viscosity, low volume electron donor. We're injecting this in the Plume area around 700 meters down gradient from the source zone.
This Plume stop barrier, it's a liquid activated carbon that is being installed to mitigate against the further off-site migration of PCE, impacting a municipal drinking water supply well.
Access to this injection location was not easy because immediately beyond the source area is a dual carriageway and a railway line, followed by a dense forest. A new road and side road had to be constructed in the forest to provide access for the works. The weather conditions added another challenge.
The injecting area is approximately 50 meters. 15 points we're going to inject. We injected it in area between 13 to 20 meters below ground. One of the challenges in this area, it was the snow. You see there's snow still, but now it's warm and it's melting very good, so we're thinking it's going very good to inject for the moment.
By overcoming the site and weather conditions, good progress has been made on site.
We are expecting it to take at least a month, maybe a month and a half, and then starts the monitoring process, which means that we are taking groundwater samples, let's say in every 3 to 4 months. And after a couple of years, 2 or 3 years, we expect the result to come as expected. The goal is to project the abstraction well, and there's no certain limit values for the concentrations, but there's a goal to minimize the concentrations and lower the concentration at least 60 to 80%.
This site gives an example of how to treat a fast-flowing aquifer contaminated with chlorinated solvents at depth, and it may prove a useful template for other legacy sites in Finland.